we go. In 12.2, we are going to factor things that we would not be able to factor in section 1. If you're unable to factor, like the number 10 that's in 12.1's worksheet, you couldn't do it unless you know how to complete the square. Completing the square is a technique you can use for the ones that don't factor using a method that we have outlined in Unit 1. So this is a way to factor things that don't factor perfectly, and using fractions and using square roots. So this is also a way to turn things from standard form into vertex form, which is something that we're going to need to be able to do at the end of this chapter. So what we're going to do is we're going to make a equals to 1 by dividing each term by a. If you're unfamiliar with what I'm talking about ax squared plus bx plus c. When this is equal to 0, we are going to divide everything by a first to make sure that a is equal to 1. If a is equal to 1, we can skip step number 1. But if step number 1 isn't done, then this is what we do first. Step 2, move the c to the other side of the equal sign. We leave an empty space for the missing piece. Step 3, we add half of b squared. There's a formula for this. It works pretty darn good if you just memorize what you're adding to each side. We're going to solve the right and we're going to factor the left. I'll show you what that means in a second. We square root both sides. Don't forget it's plus or minus. And then we solve for x, combining like terms if possible. So these are your 5 steps. I would recommend that you have your 5 steps next to the problem so that you know what you're doing as you do it. Here's how we complete the square. Let's do number 5 together. The first thing I check is my a value. Your a value is the thing in front of your squared variable. The a value here, is it equal to 1? If it is, you can skip step number 1. If it's not, you would have to divide by whatever number it is. So right now, my a value is 1, so I can skip step number 1. I can go right to step number 2. Step number 2 says, move c to the other side of the equal sign, leave an empty space for the missing piece. What's the c value on number 5? 34. We're going to subtract 34 to the other side, but what we're going to do is we're going to leave an empty space where it was so that I have room to work. Step number 1, make sure a value is 1. It is. Step number 2, move c to the other side, which we just did by subtracting 34 to both sides. And I leave some space there. How come? Because in that space, we're going to add half of b squared to each side. Now, if you don't know what b squared is, this is your a, this is your b, this is your c. What is half of b squared? What's half of b? What's b? 12. What's half of that? So we're going to add, I'm going to put this in blue right here. I'm going to add 6 squared here, and I'm going to add 6 squared there. That is adding half of b squared. What that does is it turns the left side into a perfect square trinomial. That's how come on step 3 it says solve the right, factor the left. This is a perfect square trinomial. And you don't even really have to do 6 squared, because I guarantee you this is going to factor to this. Whatever this is, boom. Whatever this is, boom. Now if I were to prove it to you, 6 squared is 36. What multiplies to be 36 is 6 times 6. How are you going to get to 12? Remember how if we were to FOIL this out, p plus 6 times p plus 6, the O and the I would add up to 12p. 6p and another 6p is 12p. This left side always factors perfectly. It may not have factored perfectly from the beginning, but by moving the c over and adding that half of b squared, that half of b squared always makes this left side factor perfectly. That's the best part. Now the right side we're going to have to solve. The right side we actually have to figure out what is 6 squared is 36. 36 minus 34 is 2. Now this is where it gets kind of interesting. This is how come you have to know how to complete the square, because not everything comes out nice and neat. We're going to get rid of this squared term, which is what we've already learned how to do in section 1. The opposite of squaring is square rooting. And I told you earlier that this is the same thing as the absolute value, which the only reason I say that is so that you remember that p plus 6 is equal to plus or minus root 2. But we don't have p by itself yet. We have to subtract the 6 over to the other side. My final answer for this, p will equal negative 6 plus or minus root 2. You cannot put these together because they are not like terms. The answers are really, what's the word? Sometimes ugly. Messy. That's the word I was actually going for. Teo. You could. The solutions would be negative 6 plus or minus root 2 in a solution set bracket means the same thing. By the way, this also tells you that if you were to factor it, that you would have something like p plus 6 minus root 2, and yeah, it would be really, really ugly. These are your solutions, though. Thank you. So that's how we complete the square. Sometimes your answers will have square roots in them. Sometimes your answers will have fractions in them. Let's look at another one. Here's number 6. First things first. I'm going to just put down A, B, and technically your C isn't C unless it's on the same side. The way we wrote this down earlier was it's ax squared plus bx plus c equals 0. Now your c is already moved over. This is technically a negative c, by the way. It's fine where it is. Is your a value, let's check step number 1, is your a value already equal to 1? Well, that's lucky. I love it when the a is already equal to 1. That way, then we can go right to step 2. Make sure you have moved the c to the other side and leave an empty space. C is already moved over. I just need the empty space. Now what I need to do is step 3. I need to add half of b squared. Now this is where it gets really interesting. What's half of 7? Some of you are going to go, oh, 3.5. Let's do this as a fraction. It makes it easier. 7 over 2 squared. I am going to strongly urge you to do this in terms of fractions. They are easier to do in fraction form than they are decimals. How come? Because 7 over 2 times 7 over 2 is a lot easier for you to do in your head than 3.5 times 3.5. 3.5 times 3.5 is hard for you to do, but 7 over 2 times 7 over 2 will be easy for you to do. Whatever we do to one side, we must do to the other. Now, why do I have that second direction here under number 3? Add half of b squared to each side, solve the right, factor the left. The left side always factors nice and neat. It factors perfectly. To what? To an m, to whatever this is, squared. If you don't believe me, FOIL it out. It will every single time. And I know I'm saying, oh, trust me. You probably should FOIL it out at least 1 or 2 times before you start taking that for granted. 7 over 2 times 7 over 2 is 49 over 4. 49 over 4. See how you can do that in your head? That's a lot easier than trying to figure out what the 3.5 times 3.5 counting decimal places and moving things over. You don't even need to grab a calculator. Plus 40. We do have to work that out. So what I would do if I were you is you find a common denominator, which is 160 over 4 plus 49 over 4. You can do that in your head. What is 160 over 4 plus 49 over 4? That is 209 over 4 equals m plus 7 halves squared. Messy. But guess what? It worked out, factored perfectly into a perfect squared trinomial. So now we're going to switch back to red. And I'm going to do the opposite of squaring, which is square rooting. What's neat about this is it's the same thing as absolute value. You can just jump right to the plus or minus if you want to. Plus or minus the square root of 209. I don't think that breaks down. But do I know what the square root of 4 is? Let me just write it like this. Square root 209, square root of 4. I'm going to put over here absolute value of m plus 7 over 2, so I remember that's why there's the plus or minus. Do you know what the square root of 4 is? That's perfect. And then guess what? When I subtract this 7 halves over here, it already has a common denominator. That's so nice and neat. My answer, it's a messy answer, -7 plus or minus root 209 over 2. You may look at that and go, huh? But it's a step-by-step process when you complete the square. You would never be able to factor this by hand with what we've shown you, which is why we're showing you how to complete the square. Completing the square is a technique that can factor anything, even this ugly stuff, even this messy stuff. And this is why dealing with fractions is easier than decimals, because you can still do it in your head. Before I move on, are there any questions? So let's just kind of go back to number 5. The biggest difference between number 5 and number 6. Number 5, when you did half of b squared, 6 squared was easy to do. But number 6, half of 7 was hard to do, so we did it as a fraction, which factors still perfectly. It's just over on this side, you had to find a common denominator first, and so that kind of got a little messy, but still doable. Now what's the next step? The next step is what happens when your a is not equal to 1. So let's do number 10. How many more? I have 10, 14. Okay, so these I got this one and one more. What happens when your a is not equal to 1? Here's my a value. I'm going to put a b value. I'm going to put a c right there. It's equal to 0. In your notes, you wrote down, if a does not equal 1, divide each term by a. Does my a equal 1? No. What do I need to divide each term by? So here's my first step. This is what happens if your a is not equal to 1. You divide everything by 2. Sometimes it will go in evenly. Sometimes it might end up as a fraction. Luckily, we have x squared minus 8x plus 13 equals 0. And now we can jump right into step number 2. This is going to be like a number 5. It's going to be a lot easier. We're going to move that c value over. I'm going to go a little quicker this time. Leave some space. I'm going to work in that space. Do you know what you're going to add to both sides? What's half of b squared? What's half of b? And when you square that, are you actually adding a negative or are you adding a positive? This is where it gets slightly confusing. Half of b is negative 4. But when you square it, what is a negative 4 times a negative 4? It's positive, right? So here's what I'm going to do. Now watch how I write this. Plus parenthesis negative 4 squared. What am I actually adding? I'm adding a positive 16. I'll work it out over here. But I put that negative inside here because I'm doing half of this. And I know that in order for this to factor perfectly, and for this to be a negative 8, this better be a minus 4 inside that squared term. Otherwise, it won't become that negative 8 for the b value. Bless you. I do that on purpose. I'm hoping you see why. On this side, 16 minus 13 is 3. I'm going to square root both sides. Got a square root of 13, or 3, I'm sorry. And I have an absolute value of x minus 4. So I know that that means x minus 4 is equal to plus or minus root 3. I'm going to move the 4 over. So x will equal 4 plus or minus root 3. Because I'm adding 4 to the other side. Pretty crazy answer. Any questions? What's the hardest that it gets? What happens if there's a y involved? What happens if the y is not equal to 0? The hardest that it gets is when you start having to switch things from standard form into vertex form. That's what I told you this could be used for. So watch what happens here. This time, I'm not going to change y is equal to 0. I'm going to leave the y value there. I'm going to divide each thing by 2. Step number 1. So I have y over 2 equals x squared minus 4x plus 2. Next, what I'm going to do is I'm going to subtract the 2 over to this other side equals x squared minus 4x. I'm going to leave a blank space right there, like that. A value is 1. My b value is negative 4. And I'm going to figure out, I'm going to add half of b squared. Whoa. This one. I was trying to switch to blue. There we go. I'm going to add half. I'm going to add half of this is negative 2 squared. I put the negative 2 inside parentheses because a negative 2 times a negative 2 is actually going to be a positive 4 over on this other side. But I put the negative 2 there so that when I factor it, I know what goes in the parentheses. What's going to go right here that I'm pointing at? It's whatever this is. So make sure that it's a minus 2 inside that parenthesis. Otherwise, you would never get that negative 4. On this side, I simplify. I put y over 2 plus 2. I'm going to just draw a little line so I know where I'm at. I'm almost done. This is almost in vertex form. I'm going to subtract 2 and subtract 2. So I have y over 2 equals parenthesis x minus 2 squared minus 2. Almost done. And the last thing I do is because I want y by itself. Even the directions say, be sure to get y by itself at the end. Y is almost by itself. I'm dividing by 2. The opposite of dividing by 2 is 2 times by 2. And I have to multiply everything by 2 over here. And this is what it will look like on the right-hand side. The 2 multiplies, just put it in front. And the 2 multiplies the negative 2. This is what y is. Y is equal to 2 parenthesis x minus 2 squared minus 4. This is vertex form. Completing the square is a way to put things and switch it from standard form into vertex form. It's a huge technique. We'll stop your notes right there.